Okay, in this video we will see the working of that um, what to say the energy meter. We will see the working of the energy meter. Working of energy meter. Okay, you will see that working of that energy meter. Working of energy meter. Basically, in energy meter, we are going to have two magnets. One is the shunt magnet and the other one is the series magnet. Now this shunt magnet, what it does is that it produces a flux phi sh, and this is an sinusoidal flux. And the equation of this flux, let us say it as an phi shm sine omega t. And now similarly, this series magnet is also going to produce another flux. Let us say it as an phi sc, and let us say this equation of this flux is nothing but phi scm sine of omega t minus beta. Okay, so these are the two fluxes present in that energy meter. Okay, now this shunt magnet is there now. The shunt magnet we are going to have an shunt coil. Okay, and that shunt coil is connected parallel to that your load. That shunt coil is connected parallel to your load. Okay, so the shunt magnet will produce a flux phi sh, which will be proportional to that load voltage. Okay, which will be proportional to that load voltage, because the shunt magnet is having a coil. That coil is connected in parallel with the load voltage. So the shunt magnet will produce a flux that is proportional to the load voltage, because the current creates flux. So the current in that whatever that shunt magnetic coil is there, no, that is the pressure coil or shunt coil, the current is IP, which will be given by that load voltage divided by impedance of that shunt coil. And now this IP creates phi sh. Okay, and from where this IP is coming? IP is coming from VL. So we can say, phi sh will be proportional to that load voltage. Okay, whatever this RMS is there, no, phi sh RMS. This phi sh RMS is nothing but that phi sh m divided by root 2 will be proportional to the load voltage RMS. This is an RMS value. Okay, that is one thing. And another thing is nothing but that series magnet is there, no, that on the series magnet we are going to have one coil that is called as a series coil or current coil. So that current coil will carry a current of that load, because because uh, because that series coil is connected in series with the load. So now whatever that series flux or series magnet flux is produced, will be proportional to that load current, because current creates flux. Current creates flux. So we can say it as an phi SC will be proportional to the load, so that is phi SC RMS. This RMS is nothing but phi SC M divided by root 2, and this is nothing but a load current RMS. Load current RMS. Okay, that is these are the two things we have to observe basically. So basically we are going to have in a energy meter two fluxes. One flux is produced by shunt magnet, we are calling it as an phi SH, it is a time varying flux, and another flux is nothing but a series magnetic flux, and it is also a time varying flux, and this series magnetic flux is proportional to that load current, because it is connected in series with that load. Now since we are going to have an this time varying fluxes, both the fluxes links that aluminum disc. Okay, that is phi SH is going to link that aluminum disc, and that phi SH is going to cut that disc. So then on the disc, aluminum disc, we are going to have an eddy EMFs, because of that Faraday's laws of electromagnetic induction. So that E1 itself is going to create eddy currents in the aluminum disc. That E1 is going to create the eddy currents in the aluminum disc. That is nothing but let us represent those eddy currents as an IE1. And similarly, the phi SC, the series flux or series magnet flux is also going to cut that aluminum disc, and that we are going to have an another EMF induced in aluminum disc. Let us say that EMF has an E2. Now this E2 will also create an eddy current in that aluminum disc. That eddy current, let us say it is an IE2. Okay, so now what is that? See, two things we are going to have. What is that? The first thing is nothing but this phi SH. What it will do? Cuts disc, and then E1 in disc. So EMF is induced, EMF E1 is induced in the disc. Because why? Because of Faraday's laws of electromagnetic induction. This is a time varying flux. So this E1 will be equal to what? Minus of or it will be proportional to minus of d by dt of phi SH. Okay, this is the E1 in disc. Now this E1 in disc will create eddy currents, IE1 in disc, IE1 in disc, and this IE1 is nothing but IE1 will be equal to that E1 divided by whatever that impedance will be there now, that impedance of the disc, whatever that impedance, or let us say them as in phasors. So IE1 and E1 phasor, and this is nothing but this one, and we can convert them into time varying now. So that impedance of that disc, whatever is there. So this phi SH is creating E1 in disc, and E1 is creating IE1 in disc. Now another one is the second one, phi SC is there, and it also cuts the disc, and there will be E2 in disc. Same principle, which will be proportional to minus of d by dt phi se. Okay, and this E2 is going to create IE2 in disk. Okay, IE2 in the disk. This IE2 will be equal to E2 by that disk impedance of the disk, because eddy currents similar to in transformer, how that eddy currents are induced in the transformer, in the same way the eddy currents are going to induce in the aluminum disk. That is how it is looking. This is the shunt magnet, and it is going to produce a flux phi sh, and we are going to have an aluminum disc like this. We are having a series magnet here, and this is going to produce a flux phi sc. Now on the disk we are going to have the doser. This is the current IE1 and another current like this IE2, like this. In eddy currents they are in. This is the disk. Okay, this yellow thing is nothing but disk. Now you can see that now here we will go to apply that Lorentz force equation or motoring principle. That is what is nothing but whenever a current carrying conductor is placed in a magnetic field, it experiences force. Now we are going to have here the two fluxes and two currents on the disk. Okay, so one force or one torque, that whatever that torque TD1 will be proportional to that flux produced by shunt magnet and IE2. Okay, this is one flux, this is one torque, and also sine of angle between this phi sh and IE2. One torque will be produced, this one, because of this thing, because torque one that is this is the flux and this is the current, so one torque will be produced, and another torque TD2 will be proportional to phi sc, and it is an IE1 and sine of angle between phi sc and IE1. So the net torque TD net is an average value. It is an average value, will be proportional to TD1 minus TD2. In this way that torque will be generated in that disk of that energy emitter. That is, on the disk we are going to have the two torques. Okay, on the disk we are going to have the two torques. One torque is because of the shunt magnetic flux and eddy currents induced because of the series flux, and another torque is nothing but the series magnetic flux and eddy currents induced because of the shunt magnetic flux. Okay, same, because whenever a current carrying conductor is placed in a magnetic field, an EM and torque and what to say, a force will be developed. These two are nothing but whenever current carrying conductor placed in magnetic field, conductor experience force. Here in this case the conductor means what? Conductor means disk. Here that magnetic field is nothing but phi sh and phi se, and these currents are nothing but IE1 and IE2. Okay, that is the thing. This is the basic working of that energy meter. Thank you.